Welcome to session 2. The first thing that we're going to be learning today is on how to store variables in the computer so that we can access them later. There are effectively three of these kinds of data types, primary ones at least, and they are as follows. Strings, which store words, integers, which store numbers, and booleans or bools, which store true validities, or in other words, whether something is true or false. Now that may seem trivial until you realize that all a computer effectively does is store binaries, zeros or ones, to dictate which pathways, themselves behaviors, to enact via a series of on or off switches. Now you'll notice that these lines are in green, and that's because I'm actually just commenting by utilizing the // keyword. Effectively, they are just for clarity purposes. The computer doesn't actually run these lines or even recognize that they are there. They're just used so that the developer can more easily keep track of what they're doing and organize some of their materials. They are completely optional and can be disregarded. Okay, so let's actually create some of these data types. It's fairly simple. We just initialize them using the let keyword followed by the mute keyword if you want to be able to change the value later, followed by the name of the variable, followed by colon, and the data type itself. We can then assign values to the variables like so, or even merge the two as such. With that said, it's time we start doing things with these variables, aka via statements. The logic is as follows. If a certain condition is met, we do X. If other conditions are met, we do Y. If none of the conditions are met, we do Z. They are as follows. If parentheses, then bracket. Else if parentheses, then bracket. Else no parentheses, then bracket. So then what do you want your computer to do? That's the question a programmer should start with. Try working it out with comments. Here's an example. Let's say there was a ride in an amusement park and we were trying to create an algorithm that told you whether or not a person was tall enough to ride in it, disregard a sensor. Technically these would vary depending on the situation, A scan, B scan, C scan, but we're not there yet, so for now we will hard code them. How can we get this to work? Well, what do we need to do? We have to decide whether a person is tall enough to ride safely. Yes, under what conditions? 150 centimeters. Well then it's simple. We just have to check if a person is above 150 centimeters, below 150 centimeters, or at 150 centimeters. Anything conditional can then be implemented using if, else statements. If true, aka height is greater than 150, then comment tall enough to write, aka print line tall enough. Else if false, aka height is less than 150, then comment too short to write, aka print line too short. Else, if none of the above, null parentheses, aka height is equal to 150, then comment exactly the right size, aka print line just right. Notice the delineating iterations. We can replace print line with greater degrees of output procedures as we slowly become better coders. The great benefits of abstraction. Valid operators are as follows. Equals, which checks if two values are the same. Exclaim equals, which checks if two values are not the same. Greater than, which checks if the first value is greater than the second value. Less than, which checks if the first value is less than the second value. Greater than or equals to, which checks if the first value is greater than or equal to the second value. And less than or equals to, which checks if the first value is less than or equal to the second value. You can also combine validities with the ampersand symbol, which makes it so that all of them have to be true. Or detach validities with the bar symbol, so that even if one of them were true, the whole statement reads as such. Sometimes, however, given necessities are continuous, we have to process the same thing multiple times until we achieve our desired success. As such, we have the existence of for parentheses, while parentheses, loop parentheses. Essentially, these keep running until a condition which the developer implements ends up triggering. And they work as follows. For loop, for x in 0.10 bracket. Essentially, x starts from 0 and gets incremented by 1 for every iteration, bracket trigger, until it breaks at x equals 10. While loop, while x is less than 10, bracket. Basically, this cycles until the x is less than 10 clause fails, which you can implement via statements in the bracket. Loop, loop bracket until break. Simply put, this loops endlessly until the break flag triggers via break, often proc via if statements.